Hello again. This video will give an overview of the Python scripting interface for EMSlice. So to start off with, on the right hand side of the window we have a text box which accepts Python code, and below that we have an output text box which outputs the result of the Python code that we enter. So for example, if we simply print 0 and run that, the output is 0. The purpose of the Python scripting interface is to give you more control over EMSlice, customization, etc. I've got quite a bit of sample code that I'm going to use for this demonstration. So the first example will simply import the control module. Control.clear will remove any current simulation data that's been created, and control.start network building will start a new building network. If I run that, we end up with an empty building network. So if, for example, this one had 3 receivers and a radio transmitter, and I ran this again, that would remove the network we had and create a new one. For the next sample, we want to import from the build module as well, and want to add to that building a source and a test point. So a source is like an access point, or a radio transmitter, or a base station. A test point can be a radio receiver, a mobile phone, a Wi-Fi user, etc. Because we have a building at the moment, I can comment out the clear and start network lines, and so we will only add source and add test point to the existing network. I could continue this by adding a few more receivers and maybe add another transmitter or 2, and then if I wanted to, I could uncomment the clear and start network lines, so that if I ran this now, it would clear the whole existing data, start a new building, add 1 source and 1 test point. That's the result. We can also use the scripting interface to add barriers, so build.add barrier, and then we have the coordinates of the points where the barrier passes through. So that script that I just ran cleared the existing network, started a new one. I commented out the add source and test point for now, and I just ran add barrier, and the add barrier ran through the points -50, 50, 55 and 15.5. So -50, 50, 55, 15.5. And this way we can add all the walls within a building. We can also, for example, create a whole network, so clear the existing building, or clear the existing simulation data, start a new network, add a barrier, add a source, add a test point, run ray tracing, and then do export. So if I run this, this has now added that same wall, a transmitter and a receiver, run the ray tracing and exported this resulting data. And the export went to the home mic desktop exp folder, which is desktop exp has created these files, which have just appeared a moment ago. So if I open the RX0 file, I see that there are 6 propagation paths from the transmitter to the receiver. 5 are 5 meters in distance, line of sight, and 1 is 20 meters distance, not line of sight, which, if we compare to the result, we have these 5 line of sight paths and 1 non-line of sight path. We can also, so for example, if you already have a simulation that we've built and we want to add to it or edit it, for example, I have this file saved to my desktop. So if I open it, this is a simulation I built some time ago. It's only the walls, internal and external, of a domestic building with no transmitters or receivers. So if I remove that, I can open that file through the Python API, which is control.opensim file, and I can save that file also through the API. So if I wanted to, I could open it, make changes, add elements, and then save that, or I could start a new file, start a new simulation and save. So if I run that script, I've opened the file, which we see, and I've saved it to this new file name. I can also use the Python API to do urban simulation modeling. So this script uses the same control.startNetwork function, but instead start an urban network. It will add 3 city blocks to that network, and so if I run that, got an urban network with 3 city blocks. I can also create an urban network and import an OpenStreetMap file. So this uses the build.setSystem param, which sets the model buildings parameter of the system, which in this case is an urban simulation, and it sets that parameter to an OpenStreetMap file, which is small.ism on my desktop. So if I run that, I have a new urban simulation model with an OpenStreetMap file loaded into it. And then I can add transmitters and receivers, etc. in GPS coordinates as well. We can also use the Python API to create mobility scenarios. So for example, in this scenario, I cleared the existing model, which was the urban network plan that we just had, so that's been cleared. We've started a new building, added a way line, which is that line that we can see now. You notice that line is added in 3 dimensions, so effectively a small spiral, just for demonstration purposes. I've set the speed parameter for the test point to be 0.5, and I've set the wayline parameter of the test point to be wayline 1. And so if I go to time management, run through the first 45 seconds, half-second intervals, and we see this radio traces out this different path along the wayline. We can do more complex mobility scenarios as well. So for example, in this scenario, I have so I've cleared the existing, which is the initial receiver and wayline. Added 6 waylines, which are the crosses we can see. I've added 6 receivers, which are at the beginnings of the wayline, and I've assigned each receiver to a wayline. If I press that, if I play that, we see how the receivers are moving along the waylines. If I reduce the time step, it makes it a little bit clearer. So this might be Wi-Fi users within a building, cars moving through a city, many applications. This can be indoor, outdoor, urban, rural, and that covers a brief overview of the Python API available through EMSlice at the moment. All the functions used within this video are documented within our user guide, and I invite any comments, questions, thoughts or feedback. So if you had any thoughts, any opinions, any feedback, any questions, please feel free to drop us an email, and thank you for watching.